Hello, thank you so much for joining us. My name is Lynn. I am a customer service rep here at WarmlyYours. Today I am joined by the wonderful.
You're talking to me. My name is Scott. I'm from Warmly Yours also. Thanks for coming, everybody.
Yes, thank you so much for joining us. So today, like it says here, we're going to be talking about installing heated driveways. We're going to be going over our snow melting systems, and we're also going to be going over some example projects. So if you have any questions, please be sure to ask. If you don't ask them, or if we don't see them right away, we'll definitely get to them by the end of the presentation. You can type those either in that sidebar chat or at the bottom of the screen in the Ask a Question module, and we'd be happy to answer any questions you might have really on any topic, but especially snow melting.
And if you're watching this on Facebook Live, then we have somebody watching the live chat area there too. So feel free to chime in there if you decide that you'd like to.
Yes, thank you. All right, so like I said, we're going to be going over our snow melting systems. We're going to be talking about installation underneath asphalt, concrete, and pavers. So our electric snow melting systems are designed to be embedded in either pavement like concrete or asphalt, or in the mortar or sand that would be going underneath pavers. And these are really designed to evenly heat the surface of the area so that any snow or ice will melt and eventually evaporate and not refreeze either. So we're going to be kind of going into if you want to have the system automated versus if you want to have it, manual, turning it on and off, things like that. So there's a lot of ways to really customize these systems to you and how you plan to utilize them.
Yeah, and that leads us to our first question since we were talking about questions here just a second ago. And we always ask for questions ahead of time. And we got a question from Mark L. Saying, can this be installed with HBP quarter-inch chip? If this is like a chip seal where they chip it and then seal it, this product is not designed for that. The product is not compatible with 1/4 inch chip seal. Or gravel. We get questions all the time. Can I put this in my gravel driveway? And the answer to that is no. It does not comply with code requirements. It needs to be protected from by a hard surface that can't wear away. The problem with gravel is it wears away. Years go by and you'll see the gravel. Eventually you'll have two ruts, and eventually it'll get down to where the cable is. That's why you can't use it with gravel. And the anatomy of the system will not work with chip and seal. So if that's what you're looking for. So that was a great question. Thank you for that question ahead of time. And we've got the first one answered. If you have any other questions, feel free to let us know.
Absolutely. So, Scott, can you tell us a little bit about testing the snow melting system to make sure that, kind of to start off that we're working with a working system?
Yeah, the last thing you want to do is put in a system that doesn't work. So what you ideally want to do is you want to test it to make sure it's good. Well, the way to test it is with a mega ohm meter and an ohm meter. A mega ohm meter sends voltage down the wires to check the insulation between them. So really it's an insulation tester is what a mega ohm meter is. So it's making sure that no power can get from the heating wires to the ground. There's actually 3 wires in the heater. 2 of them are heating circuit and 1 of them is a ground. So you want to make sure that no voltage ever leaks to ground. And that's what the mega ohm meter does. It shoots 500 volts down the line, and then it has one clamp on the ground to see if any power goes from that into ground. And if it does, it'll say, oh, you've got a problem. So you're going to need to get one of these, or most electricians have them. Just make sure that the electrician knows this ahead of time, that they're going to need a mega ohm meter along with a regular ohm meter, because the ohm values are written on the mat, on a sticker. So you want to make sure those ohms are correct and that the mega ohm test is good, so you don't have any leakage into ground.
Absolutely. So we offer smart plans here at WarmlyYours, and what these really are layouts of the space that you want to heat, showing our products in that space and how they'll fit, how you'd be cutting and turning them, and getting the coverage that you're looking for. So this is a really great example of a smart plan. You can see the actual, it'll show you where you'll be starting and ending each of the mats, where you'll be cutting and turning mats as needed, as well as at the bottom of the smart plan, there is is a lot of information that you'll want to look over, including electrical specs. So things like the total wattage for the system, the breakers needed. That's one of the biggest things that you'll want to be aware of before starting the project. And then other things like operating cost.
Now, this job was an asphalt job, so this job requires an over temperature sensor. Asphalt jobs require these to make sure that the slab doesn't get too hot and turn it to soup if for some reason somebody leaves it on manually in the middle of the summer. So what that does is that you don't have to worry about that with concrete. Concrete doesn't turn to soup, but asphalt, when it gets really, really hot, can get really soft. So you want to watch out for that. That's why there's an over temperature sensor, and that's why we always quote specific controls, which we're going to get into later, why we do that with specific types of installations. If this were a concrete job or a paver job, you don't have to worry about pavers getting too warm. You don't have to worry about concrete getting too warm. The only thing that you would do is if you were a paver job or a concrete job in one of the states that says you have to have something sensing the temperature of the slab, because there are some states that have that in their electrical code because they don't want a slab to get too hot. If it gets too hot, there's no need to keep heating it, right? So you want to mitigate the amount of power that is being used. So usually that's an electrical part of a building code. So if you are building, I believe in New York, Rhode Island, maybe Washington State, but I don't remember exactly. There are certain places that say you have to keep track of your slab temperature, and just let us know that ahead of time. Automatically we'll know in certain states that you have to do this. But sometimes people buy systems for their second home instead of where they primarily reside. So their address that we would have would be their home address as opposed to the address it's going into. So that's where you need to make sure that you keep track of that. What's great about this installation plan is we get this question all the time. How much power does it take? How many breakers do I need? What kind of breakers do I need? How much power does this use? All that information is right down here in the lower right-hand corner. It may or may not be visible to you, but it tells you what control is going to be used. It's going to tell you what your total amperage is. It's going to tell you how many breakers you need and what that size of those breakers are. So all of that information is figured out for you. You don't have to do that yourself. One thing people go is they try to figure out, oh, what size mat should I put here? What should I put there? I don't know how this is going to fit. What do I do? Instead of sitting there trying to figure it out, just give us the dimensions and we'll tell you. So it's very, very important to do that, and we're here to help you. So that's the thing, you take advantage of our experience. So that's all the information that's included down here, and you'll also get an electrical plan for your electrician and go, here you go, this is what we need. Do I have this or not? So that's what this smart plan is doing for you, besides just showing you how to lay it out.
Awesome. So kind of talking like we started already about asphalt installations, we have a really good cross-section here that's going to show each of the layers for an asphalt install. So Scott, can you kind of tell us what we're looking at here?
Yes, this installation requires 2 layers of asphalt. One of the first questions we always get from people doing asphalt is, can I put the cables on the gravel and then put 1 layer of asphalt over the top? And the answer to that is no, because gravel is not something to depend on to protect it. So you need to put down a base coat, a binder coat, some people call it, down that's 2 inches thick, and then you use a machine to lay that out, and then you can steamroll it and get your 2-inch, then lay the product on top of it, and then come back with asphalt put over the top. And that needs to be at least by code 1.5 inches, but we also suggest a 2-inch layer of asphalt on the top. So if you're thinking about doing 1 3-inch, people love this now, 1 3-inch layer instead of 2 layers. It needs to be 2 layers. So we get that question all the time. So I just wanted to make sure that we brought that up right away.
Yes, absolutely. So starting with that foundation, obviously the system is really only going to be as good as what it is laid out on. So you want to start with a gravel layer that is at least 4 to 8 inches thick and is spread very evenly to create that base layer so that the asphalt has something very secure and very even to sit on. If you're going to have an area that's going to be very high traffic, this is especially for, things like commercial installations, stuff like that, you'd probably want to be looking at even bringing that gravel layer up to about 12 inches thick.
And you can see they're using a paving machine here. That's A-OK because we're putting down the binder coat.
Exactly, yes. So that binder coat or that base coat should be at least 2 inches thick. And then that top coat that we had talked about earlier, or the top layer rather, should be at least an inch and a half thick, but you really don't want it more than 2 inches. So you want to be a little bit careful with that top coat to make sure that you're getting the thickness that you need. Can you kind of tell us, Scott, about whether or not we should be using paving machines?
Yeah, paving machines don't go over the top, but we're showing you here how to get that asphalt in a machine on top of the product without carrying it in wheelbarrows. So what you do is you can see here the binder coat is down here, and the heavy equipment is going on the binder coat and dumping asphalt over the top that's worked by hand, and then a roller over the top. You can use rolling machines, that sort of stuff over the top, but you can't have a paver machine that sits down and starts dragging across, because you will completely destroy the wires. So what's done here is the binder coat is done, and then we have all of these cuts and turns done like in the plan. So if you take a look up here at that plan that we did, all of these panels are already cut and placed on the side of the driveway. So these sections are all cut. We've cut them. Here's a 15-foot run, then here's a 4-foot run. These panels are all cut. There's a 20-foot run, 20-foot run, 20-foot run, and then these are cuts and turns. These are all done ahead of time, so as the machines come along, you drag them in place, lay them down, the machine pours asphalt over the top, and the person uses the asphalt over the top, and then the machine comes in, and then you lay more down, the machine comes and dumps more down on top of it, and you work your way back using the paved area that you've already got to have the equipment go back and forth on. You never ever want to run your equipment over the cable. Never ever run over the cable.
Yes, definitely something we want to hammer home.
So those are the layers that you're going to have, and that's how to get that top layer of asphalt onto the top.
Yes, and then from there, so once that base layer is down, that's when you'll lay out your snow melting mats. And like you had said, Scott, obviously these were already pre-cut, kind of pre-configured to make sure that it's a very simple layout. They can just more or less walk it across the base coat.
Right. The last thing an asphalt company wants to do is to wait for you to do cuts and turns, or to lay out loose cable. They don't have the time. The asphalt's going to go bad in the truck if they don't have a heated truck. So you have to get it there and get it done. So that's why you have all this done ahead of time. So we're going to be talking about other stuff you need to have done ahead of time to make sure that you're not wasting asphalt people's time or the concrete people's time, because concrete usually has more than just your particular driveway in the truck. They've got to go somewhere else with what's left. So a lot of times time is money to them, and they will not wait for you to do that. So you need to make sure that you test this before you put it in. The electrician should be here while it's being installed doing tests all the time. So your electrician is not just going to show up the day of the installation and go, oh, looks good to me, and then leave. They're going to be there ahead of time. They're going to be there a couple days before. They're going to be there during the entire day while they're working over the top of the cable. It's going to be the electrician's job to make sure that the cable doesn't get harmed. And they're going to be testing it the whole time. So if you're thinking about who do I need to have here on this day, you need to have the asphalt people, you need to do your cuts and turns ahead of time, and you need to make sure your electrician has all of their work done, like has the conduit already cut and bent before these asphalt people show up. You need to make sure that the cable never ever comes out of the side of the driveway into the dirt. You'll never ever see it because it always has to be protected by conduit. The National Electric Code says 3/4 inch rigid conduit, but a lot of local people, local codes differ all over the place. There's no way we can keep track of 4,000 different codes. We just can't do it. But the electrician's job is to make sure that the conduit he's using, or she, is to code, and also that it stubs into the top layer of the asphalt because the cable can't see the air. The non-heating lead must travel in conduit even as it exits the slab. So you're not going to have any cable anywhere that you're going to be able to see. Now, if you look at this drawing or this picture, you can see the green cable is the heating cable. That cable is always covered. You never ever cover it. But you have the heating cable, then you have a splice, and then you have a non-heating wire that goes to the junction box. And that non-heating lead is only 20 feet long. So that's the part that leaves the slab and goes into the junction box. Your junction boxes have to be within 20 feet because that's where the cable is only long enough to get from that area to the junction box. And you can see that junction box is right here at the bottom of the picture. That's where this 20-foot lead is going to run through the wall in conduit up to this box. And that's where your connection is going to be made to the power coming from the house. So you have to keep that in mind. You only have 20 feet of cold lead, non-heating lead. That part needs to be protected in conduit going into a junction box. You can never ever splice it together under the asphalt. That's against code and an extraordinarily bad idea. So your job is to get that wire into that junction box, and that's how you get your connections made. So you want to watch out for that. The part that goes from the non-heating lead to the heating wire is called the splice, and that splice you cannot bend it because that's the part where they're terminated together. That's where they're joined. The wires are mechanically fastened, the non-heating wires to the heating wires. If you bend that, you're going to break that connection, and now you're going to have a driveway that doesn't work, or at least that part. So those are just some of the things that you're going to look out for when you're doing your installation in this asphalt. And once again, since this is asphalt, we also have to have that over temperature sensor embedded in that layer of asphalt, and that wire isn't long enough to get back to the control in the house. So it needs to get to its own junction box via its own conduit, so it can then be extended from that junction box to the house by the electrician. So low voltage wires can never ever go in the same conduit as high voltage wires. So I've just kind of gone through the list of the things, the mistakes that people make quite often. And that's why we wanted to address them here. So very, very important. But what I love is this picture right here.
Yes, this is a great one. So this is actually showing that finished asphalt surface once that is installed between those two layers. So it's going to, obviously heat that top layer, get that snow and ice melting efficiently, and then it'll drain right down into that drain.
Right, exactly. And it looks fantastic too. So here you can see before we get to the final version is the product laid out, and this is as far as we went because we needed to get the dump in there to dump the asphalt over the top so that people could work with it while they're doing that. One thing or a couple things you want to do when you're using your asphalt tools is to remember you can't just use them like you're used to because there's electric heating cable inside there. So what you want to do is you want to use the rake turned upside down instead of raking it like this with your asphalt rake. You want it turned upside down so you can move it around as you need. Also, you want to put duct tape on your shovels because the last thing you want to do is have somebody with a shovel going like that and going right into the cable. I've fixed those systems before. So that's why I know please don't do that. So those are a couple of the things that you can work on, not walking on the factory splices, not bending the factory splices to get them in the conduit. The factory splice can never ever go in the conduit. It has to be in the asphalt or in the concrete or under the pavers. It cannot be in the conduit because it can overheat and fail. So those are just some things. Those are the common things that we talk to people about in our pre-meetings. We sometimes have meetings with the electrician and the contractor ahead of time to go over this stuff and say, here's what you need to do, here's what you need to make sure you don't do, and here are the things that you need to look out for. So that's the kind of service we get here ahead of time. We will actually talk this through beforehand with whoever's going to be doing this job for you. We'll do it ahead of time, and that way we'll get the questions answered instead of having you out there going, oh no, what do we do now? So that's what it's going to look like while you're doing your installation. You can see the mats over here on the left side. They're cut and they're sized. They're ready to go as soon as that area becomes available to pour asphalt over the top.
Yes, absolutely. So looking at a concrete installation, the cross section is going to look a little bit different for this one. So we're starting again with that compacted gravel base between 4 and 12 inches. And then from there, Scott, can you kind of tell us what we're looking at here?
Well, what you want to do, and I think this might align with the second or the third question we had from Chip D. That is, how's the feedback been from contractors of concrete? And I've talked to these guys directly, and the one thing they say is, we don't really have to worry about anything. Only thing you have to tell us is that you're going to need to have sub 3/4 inch aggregate in the concrete, which means the rocks in the mix of the concrete need to be smaller than 3/4 of an inch, because the product that we sell, the mesh, the heating wire on mesh, those mesh little squares are about 1.25 inches. So that 3/4 inch aggregate will flow right through. So another common mistake we see are people not getting the cable into the middle of the pour. There's two kinds of pours you can do. There's a 2-step and a single step. But what we're showing you here is a single step because it's the easiest and the fastest way to do it. What you do is you go out there ahead of time. Your electrician's going to help you with this. You're going to attach you're going to put concrete blocks or top hats or chairs, whatever the wording that your concrete people do. That is going to be used to prop up the rebar. If you don't have rebar, you can use 10 gauge welded fencing, and that is a good stiff, and you can buy that in big rolls at the big box stores. The people that sell fencing, it's the 10 gauge stuff. And what you want to do is you want to have that has to be stiff enough so when you walk across it, the chairs are going to hold that up. And that's what's going to keep your heating cable in the middle of the pour. You don't want your heating cable to do this, to be at the bottom, because then it's too far away from the top. So if you have 4 inches of concrete, you want the wire right in the middle of it. And the only way to do that is to have your compacted gravel, then use concrete blocks or debris. A lot of people just use debris from the work site because there's a lot of rocks and stuff that you can use to prop that up. But you have to remember to prop it up into the middle of the pour. And then you also have to tell that concrete guy to make sure that it's 3/4 inch sub 3/4 inch aggregate, so it'll flow through as it goes. If you don't do that and they put large rocks, what it's going to do is it's going to act like a strainer, and all the rocks are going to be at the top and all the liquid concrete is going to be at the bottom, which is going to make it a very unstable installation. So very, very important. You want to make sure that wire's in the middle of the pour, and the fastest way to do that is one fell swoop. Get that stuff put in and just pour the concrete right over the top.
Awesome. Yeah, those are all some really good tips. And I really like the point of, for the concrete contractors, it doesn't tend to be an especially difficult installation as long as they are aware of it going into it and what needs to be done from their end. It tends to be pretty simple.
Yeah, all they have to do is they want to mark. A lot of people will take construction flags, those orange flags that are on little pieces of wire, and they stick them into the ground. You see them all over the place when they mark the locations of utilities, where your gas lines are and that sort of stuff. They'll take some of those, and wherever the factory splice ends up, they'll put one there so they know they can tell the people, don't walk around here, because when the concrete starts flowing, you're going to be walking around. You're not going to remember what's underneath. So what you do is you put those construction flags wherever there's a factory splice, because that's going to tell them, don't walk here. And then as they work around it and finish the concrete, they can then pull them out and then finish the concrete without ever stepping on the splices. It's very, very important to know that.
Yes, absolutely. So looking at the foundation for a concrete, driveway installation. So can you kind of tell us, Scott, I know we talked about the top hats or, concrete blocks. Can you kind of tell us what they're looking at here?
Well, this is a job that I did, and I got out there and we had found that the wire had been attached to a chicken wire. The heating cable had been attached to chicken wire, which is not what you want to do. You don't want to do that. So at that point, I go, okay, here's what we have to do. We can't lay this out and pour concrete over it. We need to do a 2-step install here because it's just not resilient enough. You can't walk over it. Fortunately, it was just a walkway, so you can work over it from each side and not have to walk down the middle of the walkway. So what we did here is we did a two-step install. So you can see we've got some rebar there and some bricks to try to prop it up. But the thing is with the chicken wire, it's just not resilient enough. So we had to change the plan on the fly. And that's going to happen to you. You're going to run into things that no one has planned for. I found out that they use thousands and thousands of cable ties to hold this wire onto the chicken wire. So I couldn't just say, okay, we're going to cut these all off and start over again, because it took them like 3 days to do it. So we did the best that we could. And what we did then is we did the two-step pour. Now, I did mention using zip ties. Make sure that you use plastic zip ties. Don't use those metal wire devices that are used to join pieces of rebar. You don't want to do that because you don't want to compress the wire. Just use a plastic, pull it so it's tight and holds it in place. You don't have to crank on it because you don't want to compress that wire and cause a short. So plastic zip ties, make sure you get it propped into the middle of the pour. And you can see here on this picture, we kind of did it old school a couple of ways. You can see the first pour has been put here, and the first pour is still over here uncovered. So on this side is just the first pour, the 2 inches of concrete. This side has 2 inches of concrete, but we've laid the cables out over the top of it. And now we'll come back and we'll put another 2 inches over this area here, and that will finish it. So that's the two-step, where you put the concrete, you lay the product on top of it, then you pour more concrete on it as you go. This side still doesn't have the cable on it yet. And also we did the old school way of doing an expansion joint, which is either to use, in the old days, used a cardboard felt type device that is put between the two pours of concrete that actually keep them separated. That's an expansion joint. That allows them to expand and contract without pushing on the other one. It goes like this, and you don't have to worry about it breaking up the edges because it's not hitting anything hard. It's hitting a felt board. Well, what a lot of people do now is they just cut that with a concrete saw. And you can do it either way, but the last thing you want to do is you don't want to be taking the concrete saw over here, because you will cut through 15 or 20 runs of cable. And that's the last thing you want to do. That's why we show on concrete jobs, that's why we show expansion joints, because you don't go through expansion joints. So that's where this case would be. We either just poured concrete and came back and cut through here, or we put the felt board insulation between them, and then that is what gives you the expansion joint there. So we did 3-inch spacing on this, 2 to 3 inches below the surface. The National Electric Code requires at least 1.5 inches deep. That's by code of the national code. So that's what you're looking for. Those are the things you're going to be doing. And that right here with concrete is kind of like the asphalt job we did. This is the two-step pour. And just to contrast and rehash, this is the single-step pour, where you prop it up and just pour the concrete through it.
Awesome. And look at that. That's the finished surface of that concrete. So we touched on this already, the difference between the 1 and 2 stage pours. Is there anything, Scott, that you need to go over a little bit more in depth there?
Yeah, this joint that we're showing here is not an expansion joint. This is just simply a safety joint, or whatever it's called, a control joint. It's called different things in different places. But a control joint is where you simply, because we know the wire's at least 2 inches below the surface, they'll cut 1 inch along the top, and that will encourage it to crack there. And you can run cable through these types of control joints, but you can't run them through expansion joints. So that's the joint that you're seeing here.
Great information. Thank you. And then looking at a paver install. So we have a few different cross sections here showing a couple different examples. So this is starting out with a paver layer paver installation with finished mortar or sand, and then the snow melting mat. So can you kind of tell us, Scott, what we're looking at here?
Yeah, this is a mat job, because you can see the snow melting mat has tape that holds the cable to the mats, or to the rolls. And this is the fastest way to install this product with pavers, is to use the mesh. Also, what you can do is you can use the mesh actually to hold it in place, while you're installing it. Or if you're using loose cable, you can use another product that we're going to talk about here and tie these off, tie these wires to the subframe. Either, once again, that 10 gauge fencing, or the stuff we're going to be talking about here in a minute. But what you want to do is, when you're laying this out, this is just a normal paver job, pretty much, except that you have wires resting between the crushed gravel and the sand that you're using. One thing to remember when you're doing a paver install is never ever sit the paver on the cable. The paver should be sitting on sand. So that's where you're going to have a 1 inch or 1.5 inch layer that is going to encompass the cable. It's going to sit, the cable is going to sit inside of it, because you can't make the sand sit on top. It's going to go around it, right? So in that layer that the cables are in, it should be about 1 inch to 1.5 inches. If you're doing tire tracks, where you want to do just the tire track coverage to get you in and out of your garage, you're going to need to use mortar to hold these pavers in place. And the people, well, why do I need to use mortar to hold these? That's so much more expensive. Well, the problem is that these areas, if you're doing just the tire tracks, not the entire parking, not the entire driveway, but if you're just using that, the part directly over the cables will freeze and thaw, freeze and thaw, freeze and thaw, more than the areas that are not covered by heaters. So that is the area that's going to tend to sink as you go along, like gravel does as it gets worn away. It'll sink. Well, the way to keep it from sinking is to use the mortar across the entire width of the driveway, and now you've got something firm that won't wear away and will keep the cables where they need to be. So if you're going to do tire tracks, you're going to need to do that mortar, so 1.5 inches or inch of mortar. Then you're still going to need to use your sand that you normally do to use to set the pavers. So when it comes to these types of installs, snow melt mats are faster, just because they're a little bit more expensive, and you're going to talk about the pricing about that in a little bit. But
Sure.
but here we can see the stuff we were talking about, and that's the attachment grid. And this attachment grid is like reinforced polypropylene that's reinforced to be very strong in multiple directions. So what you do is you lay this out and you tag it down in the corners to make sure it's nice and taut, and then you can attach the cable to it. And once you get the cable attached to it, you can come back, you can roll it back up and put it over somewhere else if you want to. But the cable is going to be tied to this. So the snow melt attachment grid is pretty much what you're going to use if you're using cable. And that's what we see here. The cables, the attachment grid, and the plastic tie wraps that you're using to set those into place and to keep them still. And then sand if you're doing an entire driveway or a walkway, or mortar with sand if you're doing tire tracks.
Awesome. So the foundation for pavers, again, obviously your foundation is going to be a huge part of the installation because it's what you're going to have the entire thing based on. So you'll see in this picture that there is that gravel layer, that base layer, that's spread out before the actual snow melting system is installed. And the pavers are just off to the side until we have all that, the base layer down, the heating system done, and that sand or mortar. And then obviously we discussed the attachment grid. These come in 3 foot by 50 foot widths, or sizes, I guess I should say. And the grid is 1 inch by 1 inch. So it allows for that cable installation to be done very quickly, and to help maintain, proper depth and spacing.
Yeah, and what you can do is you can use stakes to hold this in place. Really not concrete bolts. The bolts and washers really aren't needed. That is, the bolts and washers, or screws and washers, are used on stairs. So we're going to see that a little bit later. But if you're going to be putting this in place over gravel, you can just use those lawn stakes, or that you use to secure landscaping materials there. So that's going to help you. And the great thing is they're 1 inch squares, so that helps you do 3 inch spacing really easily. You just attach it to one, then go up to 3 inches and go across, and attach and go across like that. So the spacing on the mat really, really helps.
Absolutely. So when using the snow melting mats, you're going to want to lay them out according to your smart plan again that we'll provide to you. Can you kind of tell us what we're looking at here with the stake in the picture?
Yeah, that's just holding it in place while you pull it tight and then lay it down, and then you can put areas, you can put spikes, different places to hold it down. But really, once it's held in place, you just keep a couple at the beginning of the run and a couple at the end, and that'll hold it taut enough so you can start putting your sand and mortar over the top, because you're not really going to be tugging on it a lot, but that will help you secure it in place while you're doing that. So you're going to, once again, your electrician's going to need to be here, even though you're doing pavers, your electrician's going to need to be here to do testing during the installation. So it's very, very important that you do that, because you don't want any problems as you're doing your install.
Absolutely. So from here, this is a good picture also showing that grid. I almost said metal mesh is almost the word I used, which is not accurate. So that grid there. Can you kind of tell us what we're looking at with this?
Yeah, here we can see those washers and the screws that are holding the mesh in place on a stairway. And then you're using cable ties, the plastic ones, to hold the wires at the specified distance apart to hold it there. And then that's going to allow you to put mortar over the top of it and lay your limestone caps or whatever you're going to be using on the stairs. Limestone caps is very, very popular with snow melting because you can get this all put in, put mortar in, set it, and it looks really nice, and you'll never ever know that electric heating wire is under there. But you have to be able to hold it in place. And the best way to do that is with this polypropylene mat, and hold it in place with the screws and the washers, and then attaching the cable to it.
Perfect. And then from there, once that heating element is installed and laid out, then you would do a layer of sand or a layer of that mortar. So can you kind of give us some tips and tricks on that?
Well, the board is to get you a nice flat surface. So they're going to be doing that. They're going to be moving it around. Once again, the most important part here is to get it flat. And the second, well, probably the most important thing is to make sure that the pavers aren't sitting on the heating cable. Because people always say, well, what's the big deal about that? Well, as you go along, if you've ever had paving or pavers put in your house, eventually 2 or 3 years later, a couple of them may sink a little bit. And the last thing you want them to do is sink and then hit on the cable, because every time you step on it, it does this as the bottom, looking for bottom, and instead it's suspended on the cable. So now all of a sudden your paver is on the cable, and every time you step on it or roll something across it, you're now hitting the paver onto the cable. So you don't want that. So you're going to use this to get it nice and flat, and you're going to use it to make sure that you have at least a half an inch between the cable and the paver when you set it down, because you have to compact it too once you're done.
Yes, absolutely. And then laying out the pavers on that sand or mortar surface. So again, just being really careful. You want anybody who's working on this job to be aware of the fact that there is going to be a heating system beneath the surface, and to take a little bit of extra precaution. So make sure that you're not, laying the pavers directly on that snow melting cable, and that you're being just a little bit extra careful to, treat that a little bit more with kid gloves.
Right, exactly. The cable is very, very resilient. You have to work at it to damage it. So we're sitting here talking about like it's the most fragile thing in the world, but it's not. But it's good to keep in mind that it's there, and to operate over the top of it, correctly, because you don't want to be damaging that product that you just put in. Once again, you're going to have somebody here testing it as you go along, and that's what you just have to look out for when you're doing this type of install.
Awesome. So, looking at some tips for installing snow melting underneath pavers, and really this could go for any installation. Make sure that the heating cable is not at any point crossing or overlapping itself. You don't want it to be touching, you don't want it to be too close. You always want them at least 3 inches apart from each other. You'll also want to make sure that you aren't ever at any point cutting or altering the heating cable length. So these are not the kinds of things you can purchase, way too much of and just end up, cutting the excess or shortening it, something like that. You want to make sure that you're getting the size that you need, which is where those smart plans really come into play.
Right. And the minimum bend radius is 2.5 inches on this cable. So if you had to go to 2.5 inch spacing to make it fit, that's okay. You don't want to do any less than that. 2.5 inch bend radius means that the cables can physically get no closer than 2.5 inches because of the bend at the end. Different size cables allow you to bend different amounts, and that's what the bend radius is. So 2.5 inches is your minimum, bare minimum of spacing. I can't tell you the number of people that we've talked to that have done this paver installation, and we designed it at 3 inch spacing and they did it at 4 inch spacing instead because no one gave them the drawing. And then the homeowner comes out and says, I have a spool of heating wire just sticking out the side of the pavers, and there's probably 100 feet of cable here, or there's 50 feet of cable here. What do I do? The answer to that is have your installer come back out and take all the pavers off and install it at 3 inch spacing instead of 4, because you cannot cut the wire, because it has to do with Ohm's law. And I just talked to an electrician the other day, and as soon as I said that, the light bulb went off, because you can't take a bunch of resistance away from something that's gauged to give you so many watts per linear foot because of the Ohm's value. So you know you have 240 or 120 volts, and you know there's so many ohms that you're supposed to have, and that will yield a certain amount of heat. If you take a bunch of resistance away, your current's going to go way up. So as the resistance goes down, I'm keeping Ohm's law as simple as possible. If you start removing resistance, which means cutting wire, more and more and more and more wire, amperage goes like this, up, as the length of the cable gets shorter. And eventually it gets so hot that it melts and it fails. That's why you can't just cut these in half. Oh, I'm done. I've got 50 feet extra. I'm just going to cut it off, and then we'll be good to go. Unfortunately, that's not the case. So with pavers, the good thing is you can pull all of them back up and make the space, or you can add, you can say, I'm going to give you two choices. You can either come back and do it correctly, or you can give me another free area here that you can get rid of all the cable you didn't use. Well, you know what the answer to that the paver is going to tell you. Okay, we're not going to give anything free. We'll come back, we'll install it correctly. So those are the kind of things you have to watch out for. You can never, ever cut the heating cable. And you should never, ever see the heating cable or the non-heating lead ever. It should never be visible. It should either be under the pavers or in conduit, sticking out the side, going into a junction box. So those are the things, and once again, every single day we get these questions. So that's why we're doing these webinars, is to go, oh, I remember that guy in the red shirt, he wouldn't shut up, but he did tell me that I can't cut the cable. So at least we got something positive there.
And that's all that really matters at the end
Right.
of the day. So talking about controls and different sensors that we offer. So when you look at your well, I should say, when you look at your smart plan, you'll see that we have the electrical requirements listed out for you. So this way you can determine well before making any purchases or doing any wiring that you have enough space in your breaker box. That's going to always be one of the first things you want to look out for.
Yeah, so if we take a look at this breaker box, it shows that we have 4 possible spaces that we can use here. Some people will call us, they'll have no spaces in their breaker box. So if you have 0 spaces in your breaker box, you're probably going to need to get an additional service, and a lot of people don't want to go to that expense. So if you have a breaker box that's full and you don't want to get another service, you're probably not going to have, you're not going to have enough power to do an installation. You figure a lot of these installations are right around 50 watts per square foot. That's why some people don't heat entire driveways. They do just the tire tracks, 2 feet by 30 feet on each side, 2 sets as you go, one for each wheel, in and out. And that will save you 60% of your electric usage if you just heat, 30% or 40% of the driveway instead of all of it. So first step, if you're interested in getting a heating product for your driveway, is to look in your breaker box first. See what you have and go, hey, I've got 80 amps to work with. I've got 40 amps to work with. I've got 120. I've got 200. It's good to know what you have, because then you can say, we're going to give you a drawing, and the drawing is going to say you need 88 amps. Oh, well, I have 100, so I'm good. So then we can proceed. But if you have a job that's 88 amps and you only have 2 spaces and there's 40 amps available, you're not going to get it done. So that's why the smart plan is so important. Just give us the dimensions of the area and we'll figure it all out for you. But you have to have electricity to be able to do it.
Yes, absolutely. I think that's something that is often overlooked or not thought about, and it's definitely something you want to consider at the very beginning of the project.
Right.
So our snow melting controls, as you can see, we have a lot of different options available. And the first thing you'll want to do is pick between automatic or manual controls. So all of our automatic controls are going to have a way or a feature to detect the temperature and the moisture, any kind of precipitation that's falling, so that the system will start to warm up as soon as there is any kind of snow. Whereas any kind of manual control, you would need to keep up with that yourself.
People love Wi-Fi. Wi-Fi is awesome. I love Wi-Fi. However, the Wi-Fi switch is simply a way to take your phone and turn it on and take your phone and turn it off. So it's a manual switch, just like the timer is. Now, if you're well versed in IFTTT, then you can program it to when you can have an app that works with the Wi-Fi switch, and maybe you can have the system turn on when your weather service that you have on your phone says it's snowing. So it'll automatically stay on, then you can have it stay on for 2 hours after it's done snowing, because you never ever want it to stop immediately after it stops snowing. You have to melt what's left, otherwise it's going to turn to black ice. So instead of dealing with that with Wi-Fi, and the timer is just simply a turn it, and then it'll heat until it's done heating until the time is up. All these other controls are automatic, where you shouldn't 99% of the time, unless you get like a huge snowstorm, you might have to manually turn it on a couple times to help clear, the 2 or 3 feet of snow. That is about the only time you're ever going to have to interact with these controls down here. So these are all automatic. And the zone breaker, let's talk about the zone breaker real quick. The zone breaker allows you to heat an area that's bigger than you have power for. So let's say that you have a gigantic driveway, and that gigantic driveway takes 200 amps, and you've only got 50 amps. What you can do is you can split that into 4 pieces, 1, 2, 3, 4. And what happens is that zone breaker will turn on the power to zone 1, and then it'll turn it off. Then immediately, just a couple seconds later, it'll turn on zone 2 and let it run for a while, and then turn zone 2 off, and then turn zone 3 on, and then turn it off, and then turn zone 4 on a couple seconds later. That way, you're heating the driveway, but no 2 sections are on at the same time, because if you have 2 sections on at the same time, you're going to blow your fuses or your breakers. So that's why it turns on, off, then on, off. It doesn't go on, off, off. It doesn't do that. It's on, off, on, off, on, off, and on, off. The more sections you have, the longer it will take to melt. There's no way around it. Multiple zones, a multi-zone heater like this is a compromise. It's allowing you to heat a bigger area than you really have rights to heat. So to deal with that, you have to go with the fact is it could take me 3 or 4 times longer to melt everything, because it's 1 section on at a time. And you have to wait for it to go through that progress. But it will let you heat a bigger area than you have power for. And that's what the zone breaker is for. It's allowing you to heat an area that you don't have enough power to heat by doing sections individually in rotation. So that's what that is. And a lot of people ask, well, how does it know it's snowing? How does it know it's wet? How does it know it's cold? That's done with an aerial sensor. So the aerial sensor works with this. So these controls use the aerial sensor. This value control is a sensor and a control all in one. The Wi-Fi is manual, the timer is manual, but the slab sensor that you see here is used with this economy controller. This economy controller simply takes the material, the data from the slab itself, and that's where it's going to get its information from. So you have, once again, these units, not automatic, not automatic, 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 automatic. So a lot of people say, when is it going to kick in? Well, since most controllers use this sensor, This sensor, if you look at the top, is a word that I love to dazzle people with, smoke and mirrors, is an interdigitated grid, which means there's a grid here and a grid here. They never touch. What makes them touch is water. When water gets on the top of that, it completes the circuit. It completes that circuit to send power through. So that's how it knows that it's wet. And then once it's wet, it says, is it above 38 degrees or is it below 38 degrees? If it's above 38 degrees, I'm not doing anything. I'm going to sit here and get rained on. But if it's 38 or 37 degrees or less, it'll go, hey, it's raining or snowing and it's below 38 degrees. Time to turn the system on. And then the system will turn on.
Awesome. And I love these diagrams, the sensor placement diagrams, kind of showing, how you want to start thinking about where your sensor should be located. And these are a little complicated looking, Scott. So can you kind of tell us what we're thinking about here?
As Ray Kroc from McDonald's said, KISS, KISS, keep it simple. So what you want to do is keep it simple by thinking, I need to put the sensor where it snows every single time. And that is never right up against the side of the house. Because if you ever go out and look at the side of the house when it snows, sometimes there's a foot perimeter, depending on how much overhang you have, but sometimes there's a foot around the house that never gets snowed on. That's the last place you want to put a sensor because it's not going to get snow. It has to be someplace where it always gets snow, away from the wall of the house, up somewhere where vandals can't get at it, but you have to be able to clean that interdigitated grid at the top because it's warm. And when it's warm, birds love to sit on that. And birds, when they love sitting on things, sometimes leave some gift cards behind, and those gift cards need to be cleaned. And you need to get rid of that mess that sometimes can be associated with birds. So you want to clean that every year. So you have to put it somewhere where you can get at it, but cannot be vandalized. And let's say, last thing, let's say you put your sensor here and you put it next to a shrub and they're the same height this year, or maybe the shrub's down here. Next year, the shrub's going to be here. Next year, the shrub's here. Next year. And all of a sudden, the snow never, ever gets to the sensor because it's now buried under the shrubs. So it can't sit next to a shrub. It needs to be somewhere where the shrub's not going to grow and cover it. So that's some things you want to do where it always hits, the snow always hits, and somewhere that can't be vandalized, somewhere where it can be cleaned, and somewhere where you can get at it. That's the most important thing.
Awesome. And then our ever famous spaghetti bowl, as you like to call it. You're going to want all of those cold leads, those 20-foot leads to be routed through. So all splices or extensions, anything that needs to be done should be made in these junction boxes, and these should be accessible. So you'll want them to be somewhere where you can reach them relatively easily and get to those splices, as well as making sure that if it's going to be outdoors, that it is weatherproof and rated for outdoor use.
Right, and you have to be able to get at them. So that's part of the National Electric Code. They need to be accessible, which means you can't hide them. You can't put 3 inches of dirt over the top and just say, oh, I don't like the looks of them. Well, you have a nice driveway. One of the small prices you're going to have to pay is that you're going to have to see this box somewhere. And usually you can put it in the side of the wall so people don't really notice it, but you can get at it. But you have to be able to get at those splices in case you ever have to do any troubleshooting or anything like that. Now, you don't have to deal with all the spaghetti hanging out everywhere because you can trim it to whatever your local code requires. Either you have to have 8 inches of wire available in that box or 12 inches, whatever that rule is. They'll tell you how much has to be available sticking up to make your connections to. You don't want any more of that. So just cut it off to whatever that length that is. And now you have a bunch of connections inside this thing looking like a spaghetti bowl that you just need to make connections for. And that's what there is going on here. There's a conduit that runs from this box over to the house. And that's where the power is coming from the house over to this junction box and connecting to the product in the driveway.
Awesome. And then I love this drawing kind of showing all of the different aspects of the snow melting system that are going to come into play. So it really gives you a good idea of, kind of an overview of what you'll be working with. So can you kind of walk us through this, Scott, exactly what you'd be looking at?
Yeah, this your sensors are outside, obviously, because if you install them indoors, your system will never turn on, but you'll never spend any money on electricity then either. You just went through the the activity of putting snow melting in your driveway that'll never turn on, and that's kind of counterproductive. But the high temperature sensor is going to be a high temperature limit sensor is going to be especially used for asphalt jobs. And that is going to be used with this control right here. The premium control is what you're going to be getting with asphalt because it's the one that uses that over temperature sensor. So you have that over temperature sensor here, you have the aerial sensor and it's outdoors. Problems we see with people that do this installation, they get greedy and they say, I'm going to take this wire and I'm going to run it to this junction box and then I'm going to run it here and then I'm going to run it over here. You can't do that. Induction will kill that signal from the low voltage. Also, it's against code to run low voltage wire in the same conduit as high voltage wire. So you can't do that. These will have their own individual conduits to get to the control. Notice the controls indoors. Also notice that the relay panel is indoors. The relay panels we sell are NEMA 1 relay panels that must be mounted indoors. They're not NEMA 3X, they're not NEMA 4 that go outside. They are NEMA 1. So if you're in a situation where you have to install the relay panel outdoors, you're going to need to source a NEMA 3X or a 4, whatever your local code requires, mount it outdoors and then put our relay panel inside of it because our relay panel cannot be exposed to the elements. It's not waterproof. So you can see these parts are all here and look at our connections, our heater mats. Multiple mats can be connected in a junction box, but notice there's 1, 2, 3 mats. There's also 1, 2, 3 feeds to this junction box. Not one really big heavy duty, 2-gauge wire running there. It's individual runs through conduit out here to the junction box. You can run one single conduit here into the slab if you like, if it's allowed per code. So you can check that out. But these are all running here. Relay panels inside, the breaker panel. So what the controller is just, it's telling the switch, which is the relay, to turn on and off. So power is always going to the relay panel. Power is always being supplied by GFEP breakers, ground fault equipment protection, or GFPE, ground fault protection equipment. And it is always going to the relay panel. This controller just goes turn on, turn off, turn on, turn off by the signal it gets from the aerial mounted sensor. So that's it. That's the view from 30,000 feet above, trying to not make it too scientific, but just kind of how the pieces work together. Now, we did have a question. Go ahead and ask any questions you have. Now is a good time to do that, so start typing. But we did have a question that was right up your alley, Lynn. What's the material cost per square feet for this product?
Yeah, so honestly, it will vary quite a bit because we do offer things like volume discounts and stuff like that. So obviously, the more that you're purchasing, the cheaper per square foot it will be. But looking at the actual cables themselves, you're usually anywhere from 8 to 16 watt or $8 to $16 a square foot. And for snow melting mats, you're usually closer to $10 to $20 a square foot in U.S. pricing.
Right. And Giancarlo asked, can you do permeable pavers? And the answer to that is yes. Permeable pavers have a different cross section that we can send you for that because it involves the water going through. Notice in all of our presentation materials, we do not mention stone dust. Stay away from stone dust for doing pavers because it's a bad subject because stone dust can eventually, you have a mixture of fines, is what they call different sizes. So what happens is you get some sizes that are a little bit bigger with really, really powdery stuff. The really, really powdery stuff fills the gaps between those larger pieces, so the water never lets the water go through. It just kind of runs off, and then as it gets wet, it can expand and contract. It freezes, and so stone dust is. We used it a while ago, but the paver. One of the paver associations said, you really should stay away from it because it can cause the pavers to heave, and that's the last thing that you want. So stay away from stone dust.
Absolutely. Mark asks, how much energy do you lose going into the base layer versus up to the pavers?
That's another great question that deals with permeable pavers, because permeable pavers, you have to have bigger chunks of rocks that don't allow that allows the water to go through. So you need to let that water. That's what permeable means. Well, the best transmission of heat is no air. So that's why the best transmission of heat is concrete. Second best is asphalt, and the third is pavers, because permeable pavers have a lot of airspace between those rocks. That kind of keeps the heat from getting to the top. So you get more energy efficiency with concrete than you would pavers. But maybe Mark might be going down the road of with hydronic systems is when you really have to worry about losing efficiency, because as soon as the water leaves the boiler, the temperature starts to drop. And as soon as it hits the cold pavement, it gets cold pretty quickly as it's pumped through. So the water reaching at the beginning could be 110 degrees, and when it comes out, it could be 30 degrees. Well, that leads to this area heating really well, and at the end, it's going to be cold. Well, that's where with electric, it's the same temperature at the beginning as it is at the end. It doesn't start hot and then get colder. It's hot, 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 hot all the way through. So I can't tell you, Mark, exactly. You're going to lose 4% by using permeable pavers. You're going to lose 6% by using this. You're going to lose 12% by that, because no two jobs are exactly the same. All I can do is give you a broad overview like I just did. Permeable pavers, having the most air content below the cable and around the cable, is going to transmit the least amount of heat. But they do work, because we've sold them before. So if you want a permeable paver drawing, we can send you that. It's specified by stone size at different layers, number 9 stone here, number 20 stone here, and that sort of stuff. It's all done scientifically to get that water through and away, but still be able to heat the surface above. So
Absolutely.
Great questions.
Yes, for sure. Any other questions? And, honestly, we have a little bit of housekeeping to do, so if anything comes up while we're chatting, feel free to ask away. Again, either in that sidebar chat or at the bottom of the screen.
Olivia, our fantastic assistant with these, she keeps an eye on our Facebook. Is there anything on Facebook that needs to be answered, Olivia?
So far, so good. Nothing
Okay.
from Facebook. Mark wanted to know if we can get a copy of the slides. Olivia, can you take care of that for him? Make sure that if we weren't emailing it to everybody, that we're at least getting it to Mark. Perfect. Awesome. All right. So our next webinar is going to be Thursday, May 11th. So next month, we're talking about installing electric towel warmers. So please be sure to join us for that. I know we have a lot of really cool new products in that front. So visit us on May 11th. We also offer daily trainings, usually at least once a day, if not twice a day, often hosted by me, often hosted by Scott, yours truly. So please feel free to join us for those, anywhere from usually 10 to 15 minutes. Ask some questions on any topic. It doesn't even need to be that day's topic, and just learn a little bit more about our products. And we do offer several services here at WarmlyYours. So we have a measuring service. We also have remote or on-site installation support. And then we also offer installation and troubleshooting for both floor heating and snow melting.
Yeah, we troubleshoot other people's stuff all the time.
Yes.
We'll get an email in the morning saying, I own this product by these other people, but they never call me back. So can you help me? And it's like, sure, we're here to keep everybody's toes warm. That's the main thing.
Absolutely. And for the month of April, we are offering 15% off of our snow melting system. So whether you're looking at using a cable system, a mat system, be sure to consider purchasing it this month so that we can get you that 15% discount, and visit our website for a lot more information.
I love this picture because it's tire track coverage on a really steep hill going to someone's house up the top of the hill. So that's where you're going to see a lot of snow melting applications where you have a hill that intersects with a road. This is a very important part to be able to stop before you get to the road. So even if you can't do the whole thing, the part before you get between the street and where that hill's coming down, that's where people will do that first and then work away from there. So that's just something to keep in mind too.
Absolutely. And we do love hearing from you. So be sure to fill out our survey once this is over. We want to make sure that we're talking about things that you want to hear about and things that you are interested in. So let us know what our next topics should be, and if you have any comments or suggestions.
I keep saying we should do some on ice cream and chocolate, but they
Heck yeah.
always say, no, you've got to be talking about our products. So if you like ice cream and chocolate, you want us to talk about it, I'll talk to the boss. What do you say?
She'll tell us to start our own podcast. And we would, Olivia seems to agree with the ice cream idea, so I think we're all on board. So feel free to reach out whenever you do have questions or to get a quote. Give us a call, shoot us an email, visit our website. However is easiest for you to get in contact with us, be sure to do so. We would love to hear from you and get you some warm driveways, warm floors, whatever you're looking for.
And ice cream.
And ice cream, of course. And that is all we have today. So thank you so much for joining us. Again, my name is Lynn. I'm joined by Scott. We had a wonderful time. Please have a lovely, safe rest of your day. And until next time, stay warm
And be radiant.